Welcome to Fusion Mobile Mathematics Clinic. Today we'll be treating a topic, variation. What is variation? Variation deals with the relationship between quantities, that is, how they relate. So if we say A depends on B, that means we are saying A varies or is proportional to B. The sign for variation looks like this. So if we say A varies as B, we write it A varies as B. Now, we'll be looking at types of variation. The first type of variation we'll be looking at is called the direct variation. Direct variation. For direct variation, we are looking at two quantities. So if we say F varies as B, A varies as B. So, for us to do this, we introduce a constant. So we have A equals to KB, where K is a constant. And we solve accordingly. For the next type, if we have what we call the inverse variation. For inverse, if we have A varying inversely as B, we write it this way: A varies inversely. That is, you have put it in a fraction 1 all over B. Then you introduce a constant also. So you have A equals to K all over B, where K is a constant. Let's look at the next type of variation, which we call the joint variation. This variation is the relationship between two or more quantities. So let's look at some examples. If we have A varying jointly as B and C, so A varies directly to B and also varies directly to C. So you have A varies as B and C. We introduce our constant, it will be K, B, C, where K is a constant. But if you have another example where you have A varies jointly as B and inversely as C. So you have A varies B all over C. Then we introduce our constant A equals to KB all over C, where K is our constant. Now let's look at partial variation, which is the last type of variation. Now for this variation, we are looking at two or more parts that are added. That is, if we have, for example, if A varies as a constant, or we say if A partly varies as a constant and as B. So we say the constant K plus B. Now for B, because we have B, we also introduce a constant. So this will be A equals to K plus CB, where K and C are constants. Also, if you have another example where you have if A varies as B and varies, or rather, if A partly varies as B and partly varies as D. So we have B, but we put in a constant for B. Then for D, you put in a constant for D. So you have where K and C are constants. So now we'll be looking at some examples to further explain variation. Now let's look at some questions from our JAMB past question. The first one we have is, if x varies inversely as y and y varies directly as square root of z and z varies directly as 1 over w squared, write down in words how x varies with w. And let's look at it. We take the question one after the other. The statements, the first part of it says if x varies inversely as y. So for x varies inversely as y, write it as x varies as 1 over y. So that's the first statement. And the next one is y varies directly as square root of z. So we have y varies as, and it's direct variation, directly as the square root of z. And the next thing they said, z varies directly as 1 over w squared. So write z varies directly as 1 over w squared. So we're told to write down in words how x varies with w. So from the three statements, you can see that x, from the first one, x, where x is involved, we do not have w. But we can substitute for each one of them. Like from the third one, we can substitute for z into this second one. So let's go. So instead of y, from the second expression, let's call them this first expression, second, third. From the second expression, so we have y varies, instead of z, we now put in 1 over y, 1 over w squared. So we have y square root of z, which is now 1 over w squared. So you find this square root, you have y varies as 1 over w. So now we have an expression for y. Now we put in that y, the expression for y, into the first expression. So in expression 1, we now have x varies as 1 over y. So 1 over, instead of y, we put 1 over w. Now, this will now give us x varies as the denominator, which is w, will come up to become w over 1, which is w. So therefore, in words, we now have x varies directly as w. Now let's look at the second question. Number 2. It says P varies jointly as M and U and varies inversely as Q. Given that P equals to 4, M equals to 3, and U equals to 2, when Q is equal to 1, find the value of P when M is equal to 6, U is equal to 4, and Q is equal to 8 over 5. So let's take it one after the other. Number 2. P varies jointly as M and U, so that is MU, and inversely as Q, so that's 1 over Q. So we put it together, MU all over Q. We introduce our constant, so we have P equals to K MU all over Q, where K is a constant. So they gave us P as 4, M as 3, U as 2, and they also gave us Q as 1. So let's put it in the expression. So instead of P we put 4 equals to K, or let's put the M first. M is 3, U is 2, then we have K, all over Q is 1. So this will be 4 equals to, we multiply this, 3 times 2 is 6K. So K is equals to 4 all over 6. Take it to the lowest term, 2 goes there 2, 2 goes there 3. So K is equals to 2 all over 3. So we have K as 2 over 3. So we are now asked to find P. Find the value of P when M is equals to 6, U is equals to 4, and Q is equals to 8 over 5. Now from this K we can make a relationship or a formula by putting K into this initial statement. So we have P equals to 2 over 3 MU all over Q, which is the same thing as 2 MU all over 3Q. So this is our relationship. So with that relationship, we can find what P is equals to. So P equals to 2MU all over 3Q. This will now give us, so our M is equals to 6, our U is equals to 4 all over 3 times Q is 8 over 5. So from here, 3 we go here 1, 3 we go here 2. So we multiply 2 times 2 we have 4, 4 times 4 we have 16 all over 8 over 5. So P will be equals to 16 divided by 8 over 5, which is the same thing as times 5 all over 8. So 8 goes here 1, 8 goes here 2. 2 times 5 is what? 10. So that's how we get our P for question number 2. So with these questions that we solve, I believe we'll be able to solve more questions when it comes to